Good evening, everyone. Welcome to the practical session 2. Now, practical session 1 was focused on how to handle some of the data in a very simple manner. So, there are a lot actually to understand further rather than this given context. But the stipulated time needs to be managed properly. So, if there's any possibility, actually, I would definitely do some additional recordings and share with you to go through, because there are a lot of concepts apart from the uh, outliers and EDA pre-processing parts. A lot of things we have, like we have to deal with concepts like how to handle imbalanced data sets, uh, how to deal with different kinds of anomalies, different kinds of transformations we have to do. So once it comes to practical point of view, there are a lot to do. So please make sure to do as much as then your life is much easier. Some of the content given in the course page, so please make sure to do it. And I have shared additional things from Kaggle. Please complete all of these things, then you will be a very good person in this context, because within a couple of hours it's a bit challenging to complete all of these things, as I'm always telling. One small request, please. Could you please update your name into your S number? Could you please change your name to S number? Could you please change your name to S number? You start removing the people who do not change the name to S number now. Right. Uh, so I have removed the students with without your S number. The recently joined students, please rename to your S number. Then it's much easy. Right. So I'm going to have a quick discussion with you, a nice and interesting story related to regression. Regression. Regression is not purely based on our, I mean, not completely based on data scientist point of view, but that's the starting point for us because it's a quick statistician's output, and I believe that's a nice starting point for us to understand this big story. Because if you understood one concept well, then the rest of the things it's much easy to understand because the core concept is more or less similar. That's the point that I have to emphasize. Now, I believe everyone did the Kegel work that I have assigned for you. If you missed it, please do it. If you just go to the Kegel, then go to the courses, then complete the courses up to introduction to machine learning. This week you can complete introduction to machine learning. Then you will be a good person to complete a nice work. So let's have a quick discussion. What I'm going to do, I'm going to see a regression line. What is a regression means? It's just I'll type it in here very easier way. So it's just y equals mx plus c kind of an equation. That's it. In simple terms, that's more than enough. It's just y equals y equals mx plus c. Please send the CSV file. Yes, of course, I can send the CSV file. What is this CSV file? This is testdata.csv. So I will share testdata.csv. I have shared the dataset that I'm using in this class. This is a manually curated dataset, so don't worry. It's much easy to understand. The ultimate goal is to understand the context. What is next question? Is this is a lab session or a practical session? You want a lab test or today? Is what you want? Why you people this much of interest to do the assignments and stuff? I don't know why. Shoot. I don't know. You just learn, guys. You don't want to do all these assignments a lot. Enjoy your life. Right. Here you go. Let's see. This is just like y equals mx plus c. Now, if I go for a quick discussion before I move to the actual code, let me share a whiteboard so you could be able to see it easily. Now, I have given the full responsibility, plus keep your hands out unless I have to do something, right? Because I believe not none of kids are here, right? Right, here you go. Now, students, now the story is like this. Now, if it is y equals mx plus c, I believe everyone knows what is the story is. It's just a straight line, right? This is y equals mx plus c, mx plus c. You, if you want to see anything at the end of the day, you have to find major two components. One component is m, the other component is c. If you know what are the values for m and c, you can tell anything for this case. For an example, assume this C is 1 and M is 2, assume M is 2, then Y equals 2x plus 1. This is the equation. That means in a given scenario, if we have x values, then we can tell the y values, isn't it? For an example, assume this is 0, 1, 2, 3 kind of values we have. Then if x is 0, then what is the value of y? X is 0, 2 multiplied by 0 plus 1. So this is a 0 plus 1, so the answer is 1. Here we have 1, 2 multiplied by 1, it's 2, 2 plus 1, 2 plus 1, it's 3. Then we have 2 by 2, 4, 4 plus 1, 2 by 2, 4. Can't see your whiteboard. I don't know why. You have to follow me, if I'm not mistaken. Only 58 students are following. Follow this whiteboard. External meeting participants cannot access the whiteboard. Yes. So if you are an external student, that's why I told you can't see the screen. You have to log in properly. Don't do anything, guys. I'll stop all of these things. Right? That's what I can do. Keep your hands out. Here you go. We have 1, it's 3. Here it's, sorry, it's 1, 3. So it is 2, 2 by 2, it's 4, 4 plus 1, it's 5. And it's 3, 3 to 2, 6, 6 plus 1, it's 7. Easy. So that's what this plot is telling. I'm correct, right? So what is this regression line is telling? Assume if you want to tell here what is the value in here or even in future, assume this is the data you have collected. Up to now you collected the data set and you could be able to see the data set, the real data set in here. Now you have values in here, but this is the unknown value. You don't know. In future, you don't know. If you have this equation, y equals mx plus c, then your life is much, much easier because you should be able to tell what is the next value. What is the next value means what you're doing is you're predicting. I'm correct, right? What is the next value means you're going to predict. Now you are, come on, keep your hands out unless I have to stop this one. Correct. I have a set of values in here. I don't know. Right? I have some values in here up to here. I have up to here, but not afterwards this. Data science is the place that taken out up to here. Data science can do up to here. Data science ends with a clean data set. If your data set is clean, all done, then your data set or the data scientist job is done. Now what I'm going to do is I'm going to hand over this data set to machine learning engineer to develop a model. Do you got this, my story? What we are doing is data scientist. Before the data scientists, we have data engineering team. Data engineering team is usually the people who are getting the data into the system. Then they are giving to the data science team. Data science team usually doing all these cut and chop and do modifications and stuff. Then it gives to the machine learning or ML team. ML team focused on the machine learning, AI, or whatever different names we have somehow. That people are telling main objective of those people is to tell what happens next. What happens next means the future. What happens next means the future. You are predicting. You are telling next. This could be happen. This could be happen for y equals mx plus c. This is the simplest version of prediction. Do you agree with me or not? If you have set of data, if you can find y equals mx plus c. If you can tell this is m and this is c, then your model is done up to a good level. Agreed or not? Right. Simply repeat it. Now I'll clean this. Guys, understand this concept is more than enough to understand all these machine learning models. I'll delete it again. Now we have set of values. I'll make the story much easy for you. I have set of x values. I have 0, 1, 2, 3, 4, 5. Then I have set of y values I have collected. Here it's 1, 2, 3, 4, 5, 6. This is the data that I have collected. Assume I have pre-processed, done all of these things done. This is my final clean data set. Now, I want the value for 25th. What is the y value for 25th x value? 26. Good. Any other answers? Here it's 25. I want this y value. 26. Come on. This is interactive learning session. So I need answers quickly. 26. I'll give 1 mark for every students who are giving answers. It seems yes. All right. Now it's on track. Actually, like I'm not giving even a single mark, but I want to uh, make you on the track. Thank you. Right. Good. Appreciate a lot. How comes it's 26? How comes it 26? Our brain is extremely super machine. Oh, something. Some people don't like that word. Right? Our brain is extremely super. Now, what did your brain? Here we have 1, 2, 3, 4, 5. Then it should be 6. Your brain stops here. And brain understood 1, 2, 3, 4, 5, 6. Here it should be 7, and so on and so forth. So what you understood is if it is 5, it is 6, 4, 5, 3, 4, 2, 3, 1, 2, 0, 1. Then if it is 20, yeah, right? Here we have 25. Then brain said it's 26. Only one student's brain is telling y equals mx plus c. I love it. Right, good. We have y equals mx plus c. I believe everyone learned this equation in grade. I have to stop this one if someone is taking control, because I have only option to stop this explanation and I have to go to the code. Right? This is the last warning. I stop it. I'm a very, very bad guy. I can stop all these lectures and I have to leave. If you do disturb, I'll leave. That's it. No more interactive learning sessions even. If you can't keep your hands out. Therefore, the entire class, it's a punishment for the entire class. Right? That's what I'm doing. Right? Here I have y equals mx plus c. So, sorry, y equals x plus 1. This is what you thought, what the mathematical equation is telling. Now we'll see y is x. If x is 0, 0 plus 1, here it is 1 plus 0, y is 1. Done. Here we have y equals x plus 1. Then we have x is 1. It's 1 plus 1 is 2. Done. Similarly, you can apply the same equation in here. Then what we can do? We have this equation in our head. So what we can do, take this one a bit. Right? So we have y equals x plus 1. So similarly, what we are going to do, we have y equals x means 25 this time plus 1. Now it's 26. Y equals to 26. I believe everyone agreed for this simple logic. This is not very complicated. This is a very simple logic. Everyone should be able to understand, right? Good, done. Big story done. Now, this is a prediction. Do you agree with this? This is a prediction. Why? You haven't seen the value of 25 forever. You haven't seen what is the value for 25 forever. What we did was we come up with a thought, we come up with a logic, we come up with an argument. We thought, all right, if if we can come up with this kind of a equation, y equals x plus 1 kind of a equation, then see my logic, then it should be correct for this one also. Now assume I'll do this graph. It's worked for 1, 2, 3, 4, 5. Perfect line. Then all of a sudden like this. Now what happens? Your prediction is going to incorrect. But since you trust up to here, this is the unknown story. This is the prediction that you did. So predictions are not 100% correct. You can't give a guarantee for that because you haven't seen. Tomorrow there could be a rain, right? There could be a rain. So you have no idea. You have no idea. There's no argument. There's no proof. No tomorrow. No, there's rain or without rain. But previous or historical data is telling the probability or the possibility to have this kind of a rain. That's the story of prediction. I believe you got it. Now, guys, I want to tell you, yes, of course, I can upload these videos for sure. But please remind me, send an email, guys, because sometimes if I missed it, I'm so sorry because I don't have all these things. I don't keep everything in my head. I don't have proper documents in here and there to share with you. Back and forth, I can't go. It's if it is gone, it's gone. That's it. Right. So please remind me if I haven't uploaded it. Right. Come on. We'll see. Now, what is this machine learning is doing? What is this artificial intelligence is doing? Even deep learning doing much more complicated, but more or less similar concept. What they are doing is they are come up with a model. They come up with a model. You heard this word in many places. I have developed a model, right? I have come up with and I have developed a model. What is this model? What what's the story of this model? People are telling, oh, it's taking 1,000 years to find this model and it's really complicated. But what is this model? Model is this equation. This is the model, right? Model is this y equals mx plus c. Oh, whatever equation. For this case, it's a linear model, it's a linear line, it's just a single line. So it's much easy to understand. That's why I just taken, right? But according to the scenario, you might have a linear regression, you might have a logistic regression, you might have the random forest, you might have KNN, K-mean, clustering, well, all these things, each and everything, there is a unique component called a model. That model is a mathematical equation with some factors. In the other hand, that equation could be derived into different kinds of versions. So that's the obvious scenario. Different kinds of versions means it's not change the coefficient and stuff. For an example, this is a model y equals mx plus c. But if you just change into y equals 2x plus c, 2x plus c, this is not a model. This is the same model because the mathematical component behind it is a fixed one. So the mathematical equation is fixed. So it's a one single model, though the coefficient is changed or whatever the values change. For an example, if it is 4 in here, C is 4. Now it's the same model that we are speaking, but different values can be generated. But if you have an equation like this, x squared, then we have x in here. Now this is a different model. Got it? It's based on the input and the expected output. The model depends on the input and the output. What is the input in this case? This part is my input. And what is the output? This is my output. In the other hand, what is the prediction that we are going to do? Y is value is the prediction value that we are going to do. What are the data that we are trying to feed to the model? X and its related components are the components that we are trying to feed to the computer or the machine to understand this is the model. Is it clear? Please make sure to clear it out, students. If you understood linear regression, I believe logistic or whatever regression model is much easy, right? Not the deep learning concepts. Deep learning, we have a small or minor differentiation. We have different layers and the learning type is different. But the traditional AI, all the components, nearly 90% of components are same concept. Core concept is same. So did you understood it or not? If it is not, please let me know, guys. There's a question. Will the data make a linear line like that? Or do we get an average? No, we should not get an average. We should get the raw data. In your case scenario, it makes one, but when we have data marked around the graph, it's not making extract line. Yes, of course. Yes, of course. In real world, it's really hard to find a perfect line. It's really hard to find a perfect line. Y equals mx plus c. If you found something, you are really lucky, because world we have variations. Real data, yes, of course, we don't have. Real data, we don't have even linearity. But the problem in this case is, if you do have linearity, this is the solution. If it is non-linearity, you have thousands and millions of solutions. So you should be able to think in a high level whether you are going for a linear model or not. If you have linear model, your life is much easy, but you can't find in real world. It's really hard. But this is the foundation theory that you can understand the whole concept. That's why I have taken out. In real world, yes, of course, it's a bit complicated at the end of the day. Uh, what is the difference between regression and classification? Oh, very complicated question. We'll do it later on. Um, Yes, I have removed some students. Now I'm not taking that student back. I'm so sorry. Because if they can't rename to S number, why I'm keeping in my class? I have removed it. I'm really sorry, dear. The question is, it's predicting an output based on inputs through a relationship. It's not true for every case, but yes, of course, for this case. The relationship, yes, of course, it's obvious. That's the story of feature engineering. We'll discuss it later on, how these features are connected with each other. But this relationship story is much more uh, a bit different. I don't like to specify it because relationships, we can go for data mining. Relationships much towards data mining, not for predictions. Mining and predictions are different. So I'm making a bit complicated to you now. I'm sorry, but this is the story that I can't help you out. You should be able to do it in a very like bit of like calm and quiet environment. You should understand what happens in mining. Mining is more or less finding the relationships. Mm, real world example, yes, of course, we'll do. One more example for regression. Yes, of course, we are going to do examples for regression. I'm just going through a bit of theory, unless you might be a bit complicated what we are going to do. All right. Uh, let's see. Thank you. And this is the big story of this simple linear regression model, which is creating an equation y equals mx plus c. Now, I haven't got the big question. In this class for some reason, I don't know. There's a big question that in your head you should ask me. Usually, like up to now in my classes, what I did, that question was raised. Not in this class for some reason. Any other questions? Interesting question is behind this story. All right, that's fine. That's fine. Come, I'll tell that the big problem. Now, the big problem is, guys, what I did was I have specifically focused on a single X feature. Single X feature affects to Y. You got it? But the real world scenario, Y scenarios, M1X1, M2X2, isn't it? M2X2, M3X3, isn't it? This kind of thing should be happen because there's no one-to-one mapping in this world. There's no one-to-one scenario. This feature affects this much feature affects this much feature affects this, then finally this is the story. If I go to a simple example, what is this and this, assume you are getting a new baby. This is your mother's feature genetically, your father's feature genetically, your grandfather's features genetically, mother's father, mother's mom, then father's mother, father's mom, and grandfather, grandmothers, and all of these people we have affecting for the shape of your kid, your skin color of the kid. That's the genetics. This is an equation. But model wise, this model and this model are same. Why? The concept is same. In case if your findings in your solution, in your case, if you found no, if it is power 3, here it's power 4, now it's a new model. Understood? You have to understand well. Here we have a single component, single linear regression. Here we have multiple, so it's multilinear regression. Multiple features are affecting for one single line. I believe you understood it. This is the nicest story, right? This is the nicest story that we have to come up with in many cases, but I will start with this one to make your life easy. Any questions? Any questions, please? Still, some students need quizzes. I will give assignments. Hold on. I will give quizzes in next week onwards to make your life easy. All good? Right. Now we'll move to the code. Then we can understand this very well again. Here you go. Now, what we are going to do, we are going to have a y equals mx plus c kind of an equation. This equation is something that we are going to find. So ultimate goal is to develop a model like this. Right. To do this, we have to import the required packages. In this case, I just want pandas to make the data manipulation. Then I'm going to read the data. I did it last week. Then this is my data set. So day and growth 1, 12, 2, 22, 3, 25, 4, 5, 6, and so on and so forth. There's a visualization. We'll see how this visualization to make this story understand. This is a bit complicated sometimes. So this visualization makes my life much easier. See, my x axis in number of days and my y axis is growth in millimeters. So it seems a plant. Yes, this plant growth in a linear manner, but it's not perfect linearity. Yes, of course, if it is it's a perfect linearity, then yes, of course, then you can do a nice story, right? But we don't have a nice linearity in here. But this is the plot. You can't change the real world data. You can't change the real world data. So the number of days and the growth in millimeters given here. Now, what I'm going to do is I'm going to converting into arrays of data into days and values, growth values. Here we have data, day and growth given in here, right? So what I'm going to do is I'm going to convert this day and growth in here. Up to now, any questions, please? I haven't done anything. I just got the raw model. Any questions? No, I just got this data set and I have visualized it. Then I have taken the data. Now, what we are going to do is we are going to develop our very first model, the linear regression model. It's too hard. How many of you believe developing a model is really hard? Please raise your hands. I'm asking a traditional AI model. No one? All right, very good class. Only two students are thinking it's a hard thing. Others are thinking it's very easy. Yes, of course, it's very easy. Now we are going to develop our very first model. What we have to do is we have to go to sklearn. I will quickly go to sklearn or scikit-learn. This is the place, the interesting story we have. I believe I told you to learn all of these things last week. Here we have this sklearn or scikit-learn. This product is a very interesting. You have classification, regression, clustering, dimension reduction, model selection, pre-processing, everything in here. So this is the place that you should keep in touch. Don't come to me and tell, oh, I haven't learned this. If something is not in this page, then something really interesting. Usually they are giving all these things for yourself. We have regression. We have linear regression models in here. Under the linear regression models, you could be able to see they have important from sklearn, they have import linear model. Right. We'll do the same thing there. Right. We'll do the same thing. Linear regression. Done. All right. Now this is my linear regression. I have import this model is this package consists all these y equals mx plus c story. Here we have this equation. Then I'm going to use this into a model. Now we have a model in here. This is the model, right? This is the model. Can you see this model, guys? Still you can't, perhaps you can't see, but this is the model. Here we have an equation. What is the equation in here? Please, now you can. What is the equation in here? Please, what is the equation here? Perfect. Thank you. Y equals mx plus c. You can't see that y equals mx plus c is in here, but it's in here. What I'm going to do next, I'm going to train the model. You know, training is a very complicated. Let me give a nice story since you are sleeping. Once I'm a PhD student, one of our fellows came to me and told, Machang, I took 2 days to train a regression model. Then I told, seriously? Then it's very interesting. Fully fake, Palboro, for sure. If it is a linear model, there's no possibility to have 2 days. Really complicated, full picture, right? Here we have this model dot fit. It's just one single method to train the model. That's all. What we are going to do in this case, X reshape and Y, what I'm going to do is I'm going to apply different X values and different Y values. Then I'm asking this model to keep in mind what is the best M and what is the best C for this given X and Y values. Again, I'll tell what I'm going to do in this fit. This fit is a method. What I'm going to do in this method is I have set of data. Where I have set of data, students, please? Please, where's this X and Y? I have to feed, I have to tell to the computer, to the equation, to this model, I have set of X and I have set of Y values. Where are these X and Y values I have? NP. It's not too complicated. Here we have the X and Y values. This is my X value. Here is my Y value in the table. Very good, right? The data is in here. What I'm going to do is I'm going to apply Y equals mx plus c for this data. I'm going to apply y equals mx plus for this data. Y equals mx plus for this. X is 3, y is 5. X is 4, y is 27. X is 5, y is 29. Likewise, computer would apply all these x whenever x, y, then y, then y is 12. Got it? Now computer would do all things for us. Not actually computer behind the scene. This scikit-learn package is doing all of these things. But in general, you just think our right machine is doing all of this. It's more than enough. Here you go. Now what I have to do is I have to take this X value. Don't think this reshape. Don't worry if you don't know, don't worry. It's just x and it's just y. Just think more than that, more than enough for now to understand theoretical concepts. What I'm going to do is I'm going to train my very first model. Ready? Go. Done. How fast is it? It's nearly 0 seconds I have trained my model. The biggest reason is I have just very simple data set, right? I have very simple data set, only 28 data points we have, right? I have only 28 data points. So it's nearly less than a second I have done this execute. Milliseconds of time the model was trained. Now the model was done. Where is this model now? Where is this model now? Model is in there in your model variable. For now, you just think it's in the linear regression model is trained in here. I have this variable model. The stored y equals mx plus c assigns with some value. I don't know what is m and c values. If we have m and c values, then the problem is solved. So we'll see what is this m and c values in here. Here m value is 2 and c value is 18. Now even you can do predict what is the next value in here. Assume if it is 30, 30 is x value. So y equals mx plus c. Y equals x is 30, 30 multiplied by 2 plus 18. Nearly some value might be generated. Understood the story of training a model? Here we have assigning the mathematical equation of creating this model. Here we have the model, the fit instance we are taking in here. We train the model in here. We train the model in here. After training, you don't want to do this one actually, because it's not a problem us to understand what is MNC, because it's not a data scientist's job to understand MNC. But I just want to make you, because this is the very first time sometimes you are learning these MNC values, so you could be able to understand. Here we have M and C values assigning here. All right, good, done, all good. Now we'll see this plot. All right, this is my line, y equals mx plus c line. Can you see this blue color line? This is y equals mx plus c. This is the perfect line that I have created for the linear regression line. But there are deviations. Agreed. This deviation is minimized. This deviation is minimized. Let me explain this story a bit more. Then we could be able to understand. I'll copy this one. Can I? Can I paste it in here? Oops. Go for paint. Why is the best line? How this machine understood, how the machine learned this story. That's the interesting part. You don't want to bother for that, but in near future, you could develop your very own models. That's the data scientist's job. Okay, here we have a simple line. Here I just copy pasted in here. Now students, here we have a perfect line in here, isn't it? Why it's perfect line? The distance of each dot is minimal. Can you see all these dots? It's minimal distance we have. This is the only line that we can draw? Not really. Lines in the sense 90-degree lines in here. Assume I'm going to draw a line like this. Can you draw a line like this or not? You can. Who told no? You can. Now you have to compute the distance. You have to compute distance. You can draw line like this. You can draw line like this. Can this all these lines are acceptable lines. See, all lines are lines that we can tell a regression line. But this blue color line is the perfect line. Why it's perfect? The distance of these dots are minimal. If you take any other case, if you take any other scenario, then any other of these things might be not the best line. We get an example here. Assume I'm going to draw a line like this. This line would be not the best because we have to take the distances, 90-degree distances in here. We have mathematical mechanisms for these things. I'm not going to deal with big math here, but you can do it later on. All these 90 degrees lines we can draw. Here we have 90-degree lines. Now what I'm going to do is I'm going to tell if it is like this, it's positive. Here we have negatives. So you know if it is 90-degree in here, then you can get the distance, right? All of these things. Assume this is 5, 8, 4, 3, 2, 2, 2, 2, 4, 5, 2, whatever 0 values we have. Here we have some values. Here plus values, assume the total plus in here. Here the total plus value here is 32 and the total minus values are 60. 2 will take me 62. The final output is minus 30. So this line is not a good line. But if we take this blue line, plus, if the blue line, the plus is might be plus 5. Here might be minus 4. It's 1. 1 is the best in this case. Understood or not? Measuring distance, not the angles. Measuring the distance. Is it complicated? Hard? Sometimes now you are thinking, is this machine learning? Is this data science? If it is too easy for you, now what you're thinking like that? I know that. Some students say, is that so? Is that such easier thing? Yes, of course, students. Yes, of course. That much of easier thing. If you just understood, this is a piece of cake. Believe me, developing a software is really complicated than a data. Don't tell. Right? Really complicated than a data science. Because for developing a software, we have to think about APIs, endpoints, taking the data from here and do all these big things, browser testing, thousands of millions of mechanisms. Here we don't have. If you understood, if you got the point, data science is piece of cake. You should have some maths knowledge to solve some problems because you want to come up with some equations in real world scenarios. Here, up to a good extent, we have scikit-learn and all of these packages. Even for other neural networks and other different kinds of complicated things, we have Keras, TensorFlow and stuff to solve big problems even. And nowadays, we have much more complicated, sophisticated APIs and stuff. So the life of data scientist is much easy. You don't want to specifically develop unique products, but yes, of course, in some cases, yes, of course, we have to come up with some different kinds of aspects. So that's obvious, right? So don't think a lot. This is the story of data science and machine learning and telling the prediction. Happy? It's complicated, but I got the idea. Great. Actually, I still didn't get it, sir, but I tried my best to understand. If you can tell me where you got stuck, I can help you perhaps. Yes, of course, some students don't get it all of a sudden. Um, some students take a bit of time to understand the big picture in this case. If not, um, you have to do a bit more. It depends. It depends on the different factors. Uh, but at least some good level of, we have 70 students. If you can tell me, if you got stuck specifically in some places, then I can help you, because what I believe is, if you understood linear regression, if you understood one model, what happens behind the scene, if you understood the truth, this is the story, this is the model, this is what I have to do. There are developed models, you have to apply it, get the work done. You can use ChatGPT, and I don't want to tell additional uh, generating tools. We have millions of tools nowadays. Choose it and finish off it. That's it, right? Finish it. So we have all of these things nowadays. We are in a very sophisticated world. You don't want to solve all these big math. Yes, of course. Yes, of course. I'll upload all of these things. Don't worry. I'm asking anything specifically that I can help you. Any specific place that you missed it. Anything that you got stuck. Happy? All right. I'm going to do the very first prediction now. Oh my God. Seriously, I'm a predictor now. I'll predict. I'll predict 30. What I'm going to do is, I'm going to predict 30. We'll execute this one. I'm getting 84 point something. What is this 30 and what is this 84? 30 means X, 84 means Y, right? Clear. Distance means distance between the points to the line. Yes, of course. Distance, distance means here, this dot to a line. Here we have dot. Then if you go for a 90-degree perpendicular line, then we can get a distance, right? In this case, here it's almost like 0, but here it might be some value. Here we have some value. We have some value in here. If it is positive in this side is negative. If this is positive side, this is negative side. That's all you need. Here we have 84. How comes this 84? I'm going to say 30 is my X value. 30 into 2 will get in a very simple. 30 into 2, 60. 60 plus 18, 78. If you just do the perfect calculations, 78 could be, do the real simple calculation, but the uh, true calculation is 84. If you add 31, we can predict it's 86. We can predict a big value. Still, it's there is a co-assumption. What is the co-assumption? The data set would grows as it is. The data set would grows as it is. That's the biggest assumption that we did, because we have data up to the day 30. If this plant is going exponential growth after the 30th date, then this equation is incorrect. In the other hand, my model is incorrect. My model is incorrect means my prediction is incorrect. Understood the risk? Understood the risk? You have, if you are going for this data science, please be careful to tell to your C-level, I mean CEOs, CTOs, and other big people, this is the assumption that I did. Don't expect that this would be perfect. I have nice experiences. I should not tell all these nice experience with students. Yes, of course, I have very nice experiences that I did a prediction. Oh my God, it's totally different, right? Oh my God, it's totally different. Very first, if you're doing very first prediction in your life, it's very interesting. This is just for learning purposes, but the live data and playing with live scenario is very interesting. Right. Is this the number represent the number of dates? Yes, of course. Here we have number of dates. Here we have the growth of this plant. Any questions? No questions. Oh, very good. I'm really happy with this class. All right. Actually, students, this is a very high level work that I did. If you are doing actual data science, actual linear model, you should do much more steps. But to understand, I have taken the most essential parts to tell. This is the big story in here. Clear? All good? Shall we go for an example in here? All right. Now what I'm going to do is I'm going to implement the linear regression for social media data set. This is in Kaggle again. Problem is finding the user behavior in Canada YouTube videos. Right, all right, all right, all right, all right. Still we don't have this. 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 Uh, Here we have. Yes, I found it. Finally. See how fast, how far is it? How far is it? Now I'll go with you again, another example. This is much more detailed than previous. Uh, you can go for any data set in this case also. Same data set even you can use. I'm not sure whether this will work or not now today. Perhaps it will work. We'll see. String values, we can't do anything. String values, we have to handle in a different manner. String values, you have to convert to to numeric value or something, because strings are not working perfectly in this case in real world experience. Is this number represent the number of days? Yes, of course. How MNC gets values? Because we have the model developed. Inside the model, we know y equals mx plus c. So we know the MNC. I know not we, but machine knows. Hence, machine knows what is MNC. That's what we didn't get the values in here. That's the question. Back to the session. Here we have reading values. I have taken out NumPy for numerical processing. I have taken Pandas. I have taken Seaborn and Matplotlib for visualization packages. Here you go. I'm going to read my Pandas file. pd.read CSV. Here we have set of values. I have a video ID, training date, title, blah 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 things. We have la 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 la. So that we won't bother at all. But we'll do something. Description of the dataset, video ID is here, and blah 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 things we have. So you can go to this video ID, training date, title, all these details you can go and see. Now, if you got a raw data set, assume this is a raw data set, you should not directly apply to any machine learning model. That's worst. You have to go through proper pre-processing, proper EDA, understanding any outliers, data set is balanced or not. All these things you should do at the very beginning. Now, the previous example, I haven't done anything at all. I just jump in. I assume all these things was done. My previous data set. Now, in this data set, I believe I don't know how this data set is. So what I'm going to do is I'm going to describe the data set to understand the numerical data in here. Some values are there, big numbers we have. That's good. I love it. Then we'll check any missing values are there. In my case, I will describe it. Then we'll see any missing values. In description, there are a couple of missing values are there. Other than that, there's no at all. So this heat map helps me to understand these missing values on right. Is null, df dot is null is the method to check this big story. Then it's no major issues in the data set. If there are a lot of things empty, then we have to deal with it. But fortunately, we don't have much more things. Now we'll see the correlations of these things by using a df.cor method. Cor method helps Cor method helps to understand the correlations. These are numerical values. It's hard to understand for human brain. We'll use a visualization to find whether we have correlations or not. Tell me the most correlated features in this data set. What are the values that highly correlated in this data set? ID. 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 Category ID. Is that so? Correlation means connected with each other. That means there's a relationship in these two things. For an example, what we can do, we can tell um, if rainy days are high, then number of selling umbrellas are high. There's a relationship. Rain and selling of umbrellas. If the rain is high, ice cream selling is low. There is a relationship in between rain and ice cream selling. So you should tell like that. You should tell category ID and views do have a relationship. That kind of thing should be the answer. Yeah, core method is doing that one. Core method here, the core method is telling the correlations in these values. The correlations in these values. These are the correlations. The correlations are given df.core. This df.core method is giving how these values are correlated. I have visualized it to make our life easier to understand. What are the features that having correlations? ID, I don't know, something going wrong. Likes and dislikes. Shall we see likes and dislikes? I have likes in here. I have to take it into Paint. I'll take it into Paint. It's easy for me, right? Right. Now we'll see. Here we have likes. Here we have likes in this. Dislikes here. So it's like here. So this is likes versus dislikes. Likes versus dislikes, the relationship is 0.46. 0.46. Now, if you go to this color scheme, you could be able to see if it is near to yellow, the relationship is near to 1. If it is 0 or below, it's like purple kind of a dark blue. In between, you could be able to see some values. Now, how to read this one? Here we have values above 0.6. Above 0.6, we have a weak relationship. Up to 0.8. Above 0.8, we have a good relationship. In color scheme, at a glance, the importance of this story is that at a glance, if something is near to yellow, then we could be able to see it's highly correlated. Now, by this visualization, you don't want these numerical values. Just go to yellow things. This is yellow, this is yellow, this is yellow, this is yellow. Can you see? This is yellow, 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 and all of these things are one. Well, that means it's a perfect correlated. Simply, that means this is this. It's like twins extract same. I don't want twins. We'll get the example. It's like in front of a mirror. You are in front of a mirror, so you can see the exact same image of yourself without any additional things assumed. Right. That means category ID and the category ID. Yes, of course, it's same. So if it is same, it's highly correlated in front of a mirror. Similarly, views versus views, likes versus likes, dislikes versus dislikes, and so on and so forth. All of these cases are highly correlated, extremely highly correlated. That means it's perfect correlated, 100%. It's one. One means it's extremely perfectly correlated. It's yellow, so you don't want to bother. Ignore it. Ignore it. Simply see. Now, below this one, do we have an eraser here? Oh my gosh. Right. Okay. Here again, we have one. Now you could be able to see some of uh, greenish area in here. Greenish area in here. Right? Something related to green kind of a thing. That is highly correlated. Right. That is highly correlated. Now all of a sudden your eyes are going here and there, right? Here we have 0.83. 0.83. What was happening here? 0.84, it's greenish, and here again it's greenish. Greenish in the sense much towards yellow. Here we have 0.83, 0.83. That means views. Here we have views. Here we have likes. Views versus likes. In the other hand, likes versus views. Oh my God, that means half of this area is unwanted. Half of the area is unwanted. Why? It's same. See, it's a mirror image. It's a mirror image of this story. Here we have some of the values in here. Here we give me a second. Hello, sir. All right, sorry guys. Here we have kind of relationship in here. Now you could be able to see there's a mirror in here. There's a mirror in here. It's perfectly 0 0.14, 0 0.14, 0 0.14, 0 0.14. All these things are nicely mirrored. So half of this design is not required. Can you see? This part we can delete. So this half of this part is not required, we can delete. If you are using, we can take only this part even, but I have taken the full image to explain this whole story. Next, what we are going to do is we are going to understand the highly correlated things. Here we have views. Here we have likes. So why likes versus views, we have a highly correlated. That means if the number of views are getting higher, then the likes are getting higher. Got it? It's like if you go for a graph, likes, views, it's like this kind of a line. Because if the x-axis is growing, then the y-axis also growing. Assume it's minus 8, 0.3. Tell me what you think. Minus 0.3. Quick. Perfect. Perfect. It's highly negative correlated. It's going down, right? It's highly correlated again, but whenever x growing, right? Whenever x growing, y is getting down. That's what these minus correlations are telling. That's what these minus correlations are. Now we understood the very first feature, likes versus views. Understood. Next, what I'm going to do is I'm going to see what is the next one. Here we have another one, comment count. Here we have comment count versus likes. If the likes are getting higher, the comment count is getting higher. See, I haven't done any machine learning model yet. I haven't done any machine learning model. Without even a single machine learning model, I can come up with a conclusion. See this correlation, the power of this correlation. Without any machine learning model, I can tell the comment count, whenever the comment count is higher, then the likes count is higher. In the other hand, if the likes counts are higher, then the comment count is, it's getting increase. I understood a couple of features, views versus likes. Then I understood likes versus comment count. So there's a relationship in between these two. Anything else? Now 0.8, like near to blue, we'll see anything related to blue. Here we have one more thing. Views versus comment count. It's not that much of a stronger relationship, but yes, of course, still we have a relationship in here. But if we take the rest of the things like 0.5, 0.4, no point at all. The weak relationships are telling if we take these blue color area, there's no point at all because there's no proper relationship at all. So now I have an idea to check, to do machine learning algorithm, to initiate my algorithm. What kind of features that I have to taken out? Now assume you are a data scientist. Now what are the features that you are proposing to evaluate further? Give me. What are the features that you are trying to tell, or I take these features in future for do something. Quick, guys. Some students are feeling hard. Is that so? How many of you feel really hard? Please raise your hands. How many of you are feeling it's extremely hard or hard? One. Thank you. Others? Two. Only two students feeling hard. Three. Five. Six. Seven. Eight. Okay. It's great. That's fine, students. We'll do some practicals, like we'll, in the sense you have to do, right? You have to do these practicals, then you'll get experience and understanding. I'll try to do like, it's full packed, guys. To be honest, it's full packed unless I'll do lot of practicals, lot of videos and stuff. But it's full packed my life with this assessment marking and stuff. So I'm really sorry, unless this is a nice story, very interesting. I have to take time and I have to explain all these edges one by one, then you'll taste it. This is very taste, guys. If you go to this story, if you understood it, it's super exciting, tasty. Like whatever the things that you ate in this world, tastiest, tastiest thing. Believe me, data science is more tastier than that. But you should taste it very first. At the very first day, Americano is quite bitter, but later on, Americano is very tasty. Like that. You should taste it properly. If you taste it properly, that's the taste is tasty. Different things, interesting. That's the world. Somehow, that's fine, guys. Yes, of course, back to the discussion. I feel most of you are getting tired. That's fine, guys, as usual. Here we have, can we views and likes? Views and likes. Yes, good try. Can't we remove the part like we removed in the below part? Can we remove those parts because weak correlations? You don't want to remove actually, right? We don't want to remove all these things. You just ignore. Ignore in the sense in future work, you can ignore those things. Yes, comment count. Now what I propose here is all the features apart from this uh, yellow color and blue color could take to future. That means views, likes, dislikes, comment count. I would take all these four features because even there is a small correlation, there could be some value generated in future. Even this 0.5 ratings disabled might help, and comments disabled might help in a very limited scope. If you really serious, you can take it, or else these four features are enough to take to the next evaluations. Views, likes, dislikes, can comment. Rest of the features you should throw away for now. You can keep it for future work, yes, of course, but for now you should remove it. That's what you can do in this case. Clear how I come up to a conclusion? Finding the relevant features in this case. Now, previous scenario, I have taken direct X and Y. Now, in this case, I have no idea what to do. I want to see the relationships, whether is there any linear relationship or not. Now, I have done some small analysis. I did a small analysis, then I understood we have exam. Sorry, I have some features that have correlations, views, likes and dislikes and coming from. That's a help for me. That's a quick help for me to understand this scenario. Ask me any questions, students. All right, back to the work. Now I can go for correlation removals and stuff, but we don't want to do correlations. Are helpful many ways to understand the relationships among the features, reduce the features. If it is highly correlated, 100% correlated, there are two features, X and Y, 100% correlated, then yes, highly correlated, 100, like 0.99, two features we have. What do you think? Do we need to keep these highly correlated or not? If it is highly correlated, it's like twins, nearly twins. We'll get 0.99 twins. Uh, Assume it's Mr. Sri Lanka. We have twins. We don't want to send both of them. We'll send only one. Isn't it? It's enough, right? Because other one will get definitely. So it's represented same. So what we can do is we can remove one feature from there. If highly correlated, 100% or 99.99% of correlated features, we can remove and we can keep only uh, up to some level of a correlation and non-correlated features. Now in this up to this case, what I did was I have divided into two parts. One set of highly correlated features, the other set without highly correlation. Any questions? Uh, do we have a book? I have answered it. Only practicals from Kegel. Why we want these books, guys? Do practicals and see what happens. Is this graph about how things such as views, likes, and comments affect to each of them? Not each of them, just among two of them. I will get an example here. Here we have views versus category ID, likes versus views, not with each and every. If you want each and every, yes, of course, you have to read like this: category, category ID, category, views, category, likes, category, dislikes, category, comment count. That's how you should read if you want that information. When do we have the lab test? Abbo, mata be appa. Right? You people like to do this much of lab tests and stuff. Why, students? You are interested to do the tests and stuff. Everyone is asking when we have lab test, when we have TMA, when we have cat 1, cat 2. Ayo, I don't know. Seriously, do you learn? You want to learn or to do lab tests and stuff? Testing yourself. To test, guys, you should learn first of all. So please learn. Understand the concepts. Understand what is it. First understand what is this. Then you do test. test to evaluate where you are, whether you grasp it or not. You, I don't know, dear. Yes, just you. Okay, let's see. What is the next question? It's like normalizing database tables. Normalizing database tables are different story, guys. Actually, normalizing database tables are to handle the redundancies and stuff. But in this case, we are not much towards to that. Normalizing database is a slightly different story. But you can think it's like, but I don't think that is a good example to train your brain. So that's a different story. Don't. So just think like this. This is a new story. That's fine. Any questions? Is it really hard to grab the theory here? No, it's very easy. Could you please give me any suggestions or ideas to grab these things? Do practicals. Do practicals. Go to Kaggle and do all these coursework. Like coursework in the sense I have sure is, if I'm not mistaken, do the practicals in the Kaggle. I believe you can do whatever the things. You don't want to do anything. You just go to Kaggle and do practical students. If you learn theories, millions of theories, you can't even earn a cent. Believe me. If you know the whole theories in this world, if you know in and out theories in this world, you can't earn even a cent. If you know practical, even one single thing, you can earn a lot. So spend 5 minutes of practicals than spending 5 hours of theory. Learn the theory. What is this? Now, for an example, if I don't know what is this correlation plot, this heat map, if I can't interpret it, then it's a big problem. Theoretically, I should know if it is above 0.8 and stuff. This is should. Then I should explain it, interpret it. That's all. Right? That's all. That's all. So do it. That's enough. Do practical scenarios. Do as much as practicals. Get your hands dirty. Then you learn. Unless you learn theories by heart, katapadam karai girawa wage, that's it. You don't know anything what happens in the real world scenario. What to do? What we can get out from this? How to interpret it? That's the requirement now. We are going to management meetings very soon, like not in government places. Don't go for there. No point at all. Go for private place and try to explain this scenario. They are happy. Oh, seriously, because it's monetarily oriented. It's earning. In the core is the fundamental is earning. Right. So do some practicals. We don't need tests. No need good. Don't. There's a lab test date. I don't know, guys. It could be somewhere next month or something. We'll do it later. That's no need test. Uh, Activity diary says lab test. That's why I ask. Lab test is that so? Activity diary says it's lab test. Uh, Seriously, we'll ask to remove those things. I'm so sorry. Uh, Seriously, I don't think so. Let me check. No, dear, it's in lab 1, lab 2, lab 3. Lab test is Sunday, June 21st, Saturday. Saturday, June 21st, as per the schedule, but it's online test. I don't want to keep any online test because you'll cheat as much as. So we'll do physical exam for that day, right? So you have time, June 21st, till June 21st, you practice. You do practice, and there's a TMA 1 due on 2nd of June. If I'm not mistaken, that's not for the marks. Let me check on that one also. I believe that's not for the marks, but for fun. Uh, Yes, TMA is not for marks, it's for fun. You can do it to get some understand. Ah, no, no, no. TMA 0.2 you have. Yes, you have to do the TMA. there's a certification course. I will add this Kaggle one to PMA. Then you will do it. Then you will get 0.2 also. You will get a certificate, global recognized certificate, and you are a person in the context. So you will get 0.2 for this TMA. So the lab test is 0.4 and BestCat 0.4. So the lab you should get 40 marks above. So the lab is, we have time, June 21st around. So don't worry, right? You have time. Do the practicals. I'm just kidding, right? Don't get upset. What else we have? Don't do lab test. No. We have to do the lab test. Oh my God. Practical without theory is blind. Theory without practical is lame. Isn't it? Yes, of course. Kaggle is the key. Yes, of course. That's my recommendation. Kaggle is the key. If you live in Kaggle, you are a data scientist. Guaranteed. Guaranteed. If you are living in Kaggle, you are a data scientist. More or less the theoretical things that I learned from Kaggle. So for sure, even I learned from lecturers. To be honest, I don't know to criticize all these people, but I believe the time that I spend alone with this code gives me much more power than sitting and learning from someone else. I I self thought, I thought to myself, this is this is that, and all of these things. Similarly, it's really hard to explain all these niche cases in this subject. It's obvious because this is not something that very easy to grab. This is something that you push yourself into somewhere, then only you can learn. So that's something bigger story. Kaggle, yes, Kaggle is the best thing, so do uh, Kaggle as much as. Can we do the lab test using Python or R? Yes, of course. You can do whatever the language. I know both Python and R, don't worry. It's not a big deal. It's very easy. Right. Interesting questions. Done. All right. Good. Thank you. Let's move to the any of student don't get my interest in speeches, right? Ignore all of these things. I'm just making you happy. Here you go. We'll see what is this. That's my quote. There you go. Yes, here we have correlations. You can deal with correlations. Guys, go to ChatGPT and ask why we want correlations. What are the important things? Where should we remove? How to remove, and all of these things. Use ChatGPT, then you can do a bit more things. And in the other hand, after doing this is a one example scenario. You can do finding outliers. You can do lot of things, whether the data is balanced data set or not, whether the data set is skewed or not. All of these things that you can do. So yeah, now I'm going to see going to have these plots to see the distributions and stuff, right? So these plots are describing these kinds of things. So you can do a lot later on. Then you can go to bivariant disk plots, two-dimensional disk plots. Here you have a big issue in this chart because it's not scaled. See, it's not scaled properly. So you have to do something for this kind of a case. So views versus likes distribution in here. So the views versus likes distribution is given in here. I have added a while plot here. Oh, something gone wrong. Comments disabled. See, you can see one is a very lengthier with a very shorter. Here it's much more breadth, but not the depth is given here. You experiment all of these things. In case if you can't understand this kind of a plot, students, what you can do is just drag and drop into ChatGPT. Then it will explain all of these things for you. Okay? Because it's not easy thing to explain all the plots in this world. There are millions of plots, so I can't explain all of these plots. You experiment it, then you learn. You see what happens. You teach to yourself. This is this. Then you go outside and teach to others, then they'll tell, no, no, this is that and all of these things. Then you fix your issues, then you are a stronger person. Because if you think you are correct, you might be incorrect in the other hand too. This is a simple scatter plot with the views versus likes. So we have a nice distribution in here. Uh, in real world scenarios, you should be able to explain this kind of a situation. You should be able to explain this kind of a situation, what happens in here. In this case, I can see nice two main distributions in here, likes distribution in here. Here again, another nice distribution here. Now you can do different kinds of things later on based on this data, and you could be able to see the uh, high data set. All this data set is we call shrink into a specific area. That's something here. Here we have data pre-processing, so we can go for uh, working with categorical data. Then we can do the things like this. Then we can see the uh, data distribution here. Here we have box cost transformation. It's again nice, interesting story. I don't have much time for this time. That's fine. Here, guys, we are going to have a box cost transformation. It's another interesting model for non-normal distribution data set we have in here. So give me a second, guys. Hello, sir. Oh, sir. Right. So here we have this box cost. Now, this is one transformation mechanism. We have log transformation, different kinds of even log inside the log. We have different kinds of transformations. We have whenever based on the skewness, based on the distribution, you could be able to tell what kind of thing we have in here, right? If the data is not distributed normally, how to handle it. If the data set is not having like this feature and that feature, then different kinds of approaches we have. Now in the previous scenario also, I have taken what we call Pearson correlation, but we have different kinds of correlations. Spearman correlation we have. Spearman applies for different story. Pearson applies for different story. So there are different kinds of variations we have. Lot of variations we have. So we have to deal with these kinds of variations. That's why I'm always telling, do the practicals, because this is something not something is to complete within a given time. So if you apply it practically, practice it, practice it, then only you know, all right, this is the place that I have to use box costs. This is the place for log, how to transform it, and so on. So somehow, well, good. Something that I now, up to now, I did a small story for EDA and pre-processing part. It's not a fully complete one. It's just very high level one, but I did for you to understand in the previous the example one, I haven't done anything. I just taken out. Example two, in this case, I just gone through a quick overview to understand and done something in here. I'm going to do some interesting part now. I'm going to see the train test split, but it's not in here. This is something again repeated. Right here, we have split in the data set into training and testing data. This is very interesting. Now, we have to, now I think you can remember that I did discuss in ILS2 uh, train test split. Now, if you go to All right, we'll do it later on, guys, unless it might be a problem, but I'll quickly explain this case. We have X train, X test, Y train, and Y test. All of these things we are doing train test split we have. So we have X value and Y value, then we are waiting the training testing set to 0.5. What is the meaning of this train test split? Means the percentage of data that we are using to train the data set and test the data set, because we have one single data set. We can't go back and forth and collect the data. So we have collected the data set. Now what we are going to do, we are trying to randomly take 50% of data for testing. Then training data is 50%. Is this a good approach or a bad approach? The question is, I have training testing data 50% and training data 50%. Is this a good process, good partition or not? Good partition. Not good, not good, not good, not good, good, not good, 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 not good. Questions are there. Here, the standard, the data set, the data scientists are using 80-20 or 70-30. That means 70% of data for training and 30% data for testing. That means the test size is 0.3 or else 0.2. That means 80% of data for training and testing 0.2. All right, that's the story in here. If you have 0.5 test size, then it's equally taken out the data set into two parts. The training data and testing data are equal. So the model won't learn a lot. Model won't learn a lot. So the probability of doing incorrect things, predicting incorrect things are extremely high, because the model needs more data to learn. For testing, we can keep 0.2 or 0.3. On the other hand, 20% or 30% of data. You just go to my session 2, then you could be see I'm explaining the same story in there also. We have a story called random state. It's just a number. You can give any number. Whatever the number is not a problem all. It's just a number that we are giving. Here the value is. After partitioning into two parts, I have X train and Y train, X test as well as Y test. Now what we have, X train and X test as well as Y train and Y test. Now what we have, now we have two parts in here, training part and the testing part. Now we can use this data, X train and Y train, for the training purposes. Previously, we have directly take our X and Y values. Now we partition into two parts. We have X train and Y train. So we have X train and Y train to feed the data. Fit would be the regression variable. Regression variable is the place that the regression model or the equation that we are taking. Previously, I have did the same thing in here. Linear regression would take that equation, this linear regression from the scikit-learn, then scikit-learn model we have y equals mx plus c equation implemented. Now I have a model in here. I have used this fit line to train this model. Understood? I have used this one to train this model. Now I have a regression model trained. After training, I can take predictions of X test for Y test. Now I have set of values. Eventually what I can do is I can do evaluate the coefficients and the intercepts as usual. Not only that, we can go for different kinds of matrices like accuracy, F1 score, precision, then we can go for R square, many things we can go for testing purposes. This is an example that I have used in this case. I haven't drawn a specific line uh, as previously. I have drawn a LM plot in this case because this is the easiest visualization. Now you can see there's a border in here. There's a border in here. This border supports a lot to tell this line. Now, according to this data set, linear regression would be not the best, obviously, because the data we can't see there's a unique linearity. If the data is in a nice linearity, then this linear regression line would be best here. But according to the given data, this is the only solution that we have. Then this is the prediction for R mean square, the MSE, and the J or the theta given values here. Then I think I did, yes, regression model. I haven't taken the regression. That's why I'm not having this one. Somehow that's fine. That's Y test is here. We have the residuals we have to go for, and we have to see the residuals in here. Then eventually we have to find the multicollinearity. But to find the multicollinearity, we have to use variance inflation factor. So if variance inflation factor, if the variation inflation factor is less than 5, there is no multicollinearity in here. In this case, if the value is 3 point this much of value, so there is no multicollinearity in this case at all. If you go for a scatter plot, then you can see this distribution again. And if you get the Stux model to tell all these things for this ordinary least square regression model, we can see all these values of this scenario. And finally, we can go for the mean absolute error, and we can go for the mean square error. If the mean square and RMSE is greater or large values, we have to think again, but it depends on the story. Be careful how this mean square where MSE and RMSE are worked. So I'm sorry, I don't have much time to explain all of these big things. You can do it a bit later to see all of these things. In the other hand, we have log errors. How these log errors are working is a nice story. I have a quick question for you to think. Yeah, this is my regression. Uh, what is my data set? Yes, this is the distribution of data set. Do you recommend linear regression for this data set or not? That's the last question for today. Please, 2 minutes, 1 minute, 1 minute, quickly. Yes or no? If it is yes, why it's yes. If it is no, why it's no. Quick. This is the distribution of data. X and Y value distributions are given here. This is not a good data set to use the linear regression. The reason behind is the data is not in a linear distribution. That's the simplest answer. If the data set is in a linear distribution, what is that? And we get the previous example. See, the data set is distributed in a linear manner. Then you can use the linear regression. If the data is distributed like this, can you see any linearity? No, you can't see any linearity in here. If you can't see any linearity, then you should not use linear regression. This is an incorrect usage. This is, see, the regression line is this one. If the regression line is this one, your answer is messed up your life. Completely missed, right? Your predictions are more or less incorrect. Is that clear, students? Where to use, where not to use, whether we are going to use this one or not. It seems your brain cells are jumping here and there now. All right, somehow I believe up to a certain level it's interesting. Sometimes if it's a physical lesson, this could be much interesting than an online session, because online sessions, our mind running here and there. Mind is slippery, so it's jumping here and there. If it is a physical session, sometimes you might be in a proper place and do all of these things, but what you do, guys? All right, all good. This is the way that we have to go through. You are adapted and you are practiced, and this is the best way that we can do in future too. We'll believe it. Any questions, please? Please upload the video without editing. Yes, of course, I'm uploading without any single editing. I'm just uploading it as it is. Seems some of students are happy, some of students feel hard. Right, don't get upset, guys. Yes, go through back and forth. Still, if you have any questions, please let me know. Uh, I I try to do explain as much as. If you have any issues, I'm in CRC, CITES office. Come to my room. I'll help you out to understand, to tell you, to explain you as much as I can. Right? I'm not. Uh, I try to give some documents to you. Then you can read those documents also. Do practicals in Kaggle, and I will share the Google Colab practical sessions also. Do practicals as much as, then you will be a genius. To understand the theoretical concept, then apply it. All right, guys. That's all for today. Enjoy the life. We'll meet again very soon with another practical. At that day, what I believe is you have completed all these basic things like partitioning and stuff. Then you are good enough to handle different kinds of aspects in machine learning. All right. All right then. Uh, Good luck and do much work. This is very interesting. Say bye bye. We'll meet soon. Good night.